Hello, welcome to this session. It is the last session of Unit 3, and in this session we are going to look at the determination of amount of ions and actual number of ions in a solution. So let's look at the objectives for the session. By the end of this session, you should be able to determine the amount of ions in solution, determine the actual number of ions in solution. So let's proceed with our first objective, and we are tackling this with a problem. So we are going to solve this problem in an attempt to determine amount of ions and actual number of ions in solution. So we have two solutions that we are going to perform the titration with. A is 0.1 molar or mole per dm cubed HCl solution. B is a solution of KOH. It's a solution that we don't know its concentration. So from this, you could tell clearly that we need to start working from the HCl. Then we now look at relation between HCl, the hydrochloric acid, and the potassium hydroxide to now look for that of the potassium hydroxide. So we have the instruction for the titration there. Let's proceed to the questions that we have to solve. We are to look at the concentration of potassium hydroxide in mole per dm cubed, as well as in grams per decimeters cubed. We are to look at the amount of potassium and hydroxide ions that reacted, and finally the number, and we are also to look at the number of potassium ions and hydroxide ions that reacted. We are to take the average volume of A to be 22.5 cubic centimeters. So let's look at how we are going to solve this problem. As usual, we look through the question and look at which one has enough data, enough information for us to start working from, and that is the hydrochloric acid. And we were given the concentration of the hydrochloric acid to be 0.09 mole per cubic decimeters. So we need to interpret that, and that means 1000 cubic centimeters of HCl contains 0.09 moles. If that is the case, then that small portion, that titer value, that average titer, that's the small portion of the volume that we used, will contain how many moles? And with that, we are going to get 0.00225 moles. If we know this, the next thing to look at is the relation between hydrochloric acid and potassium hydroxide. What is the relation? It is such that 1 mole of hydrochloric acid reacted with 1 mole of the potassium hydroxide. So the mole ratio is 1:1. What that means is that whatever moles of HCl is the same as the moles of potassium hydroxide. So from that, we can say that the moles of potassium hydroxide is the same as 0.00225 moles. Remember, that is the moles in the pipette volume. So in this case, 25. So the 0.00225 moles of potassium hydroxide is the moles in the 25. But remember, in amount concentration, we are looking at 1000 centimeters cubed or 1 decimeters cubed. So what do? If 25 contains 0.00225 moles, then 1000 will contain how many moles? That will be 1000 times the moles, which is 0.00225, over 25, which is our pipette volume, the volume of the base that we used, and that gives us 0.00225 9 mole per decimeters cubed of the potassium hydroxide. Another way we could have done that was right at the beginning. We just write the equation and then use the mole ratio. So N of KOH over N of HCl is equal to 1 over 1. But we know that N is equal to C times V. So that would be C, that's concentration of potassium hydroxide, times volume of potassium hydroxide over concentration of HCl times volume of HCl is equal to 1 over 1. Then we do our substitution and we will get the concentration of potassium hydroxide straight away. That is a very simple method. Now, the second part was to find the mass concentration of the potassium hydroxide. But once we know the amount concentration, the rest becomes easier. So to get the mass concentration, we need the amount concentration and molar mass. So we first find the molar mass of potassium hydroxide from the atomic masses, and that gives us 56 grams per mole. We do our substitution into the relation for the rho or mass concentration, and that gives us 5.04 grams per cubic decimeters. Let's look at the other part, which is moles of. Okay, so we are now going to look at the ions, but to get the ions, now that we know the moles of the potassium hydroxide, we can now come to the potassium hydroxide and then write it in terms of ions. Remember, they said we should find the moles of the potassium ions, moles of hydroxide ions. Then the follow-up question was to find the number of potassium ions and number of hydroxide ions. So we are writing the potassium hydroxide in terms of ions, or we are splitting it into ions. And that gives us potassium K plus OH minus. So let's do our mole ratio. From this equation, 1 mole of potassium hydroxide is equivalent, or 1 mole of potassium hydroxide would dissociate or would dissolve to give us 1 mole of potassium ions and 1 mole of hydroxide ion. So the mole ratio is 1 is to 1 is to 1, which means the moles of potassium hydroxide is equivalent to the moles of potassium ions, which is also equivalent to the moles of the hydroxide ions. So we can write that moles of potassium ions is equivalent to 0.00225, and that is the same as the hydroxide ions. So we know the number of ions, the moles of the ions. What is next is to find the number of ions. And here we are talking about it as if you were to count them. But since we cannot count, let's use this relation. We know that entities, capital N is equal to small n, which is the moles times Avogadro's constant, L. Here we know the parameters. N, we have found it to be 0.00225, and the Avogadro's number, L, is 6.022 times 10 to the power 23. Even if it is not given, this is a constant. So let's do a substitution. Remember, we have moles times ions per mole. So moles will cancel moles, and we have 1.355 by 10 to the power 21 ions. That's the ions of the potassium, or that's the number of ions of potassium. And similarly, number of hydroxide ions, since the mole ratio, or since the moles are the same, we expect the same answer for the hydroxide ions, and that also gives us, or doing the same thing as we did for the potassium ions, we get 1.355 times 10 to the power 21 ions. And that ends the session. You are to try these questions, and we'll meet again in the next session. Thank you very much.